Hi everyone, I am Vasumati Ram. In this video we are going to solve question related to hypothesis tests from the sample paper. This is from the sample paper year 2020 and it is question 6. There are 3 parts in this question and it is of 9 marks. So we have to make sure that we understand the marking system as well. The marking system for the examination goes like this. If it is M, it is method mark is given. A is for accuracy mark and B is for mark for correct statement or the step. And this is available in the marking scheme as well, and we should be very clear about their information, how they mark our examination answers. This is the question. At a certain hospital, it was found that the probability that a patient did not arrive for an appointment was 0.2. The hospital carries out some publicity in the hope that this probability will be reduced. They wish to test whether the publicity has worked. A random sample of 30 appointments is selected and the number of patients that do not arrive is noted. This figure is used to carry out a test at the 5% significant level. So this is the question and they want us to carry out a test at 5% significant level and come to the conclusion whether the publicity has worked or not. So we will go to the question again. At a certain hospital, it was found that the probability that a patient did not arrive for an appointment was 0.2. We need to highlight and the keywords from the question. The hospital carries out some publicity in the hope that the probability will be reduced. This is a keyword. They wish to test whether the publicity has worked. The random sample of 30 appointments is selected and the number of patients that do not arrive is noted. This figure is used to carry out a test at 5% significant level. So we have to first identify the keywords. The keywords are did not arrive for the appointment. So did not, what is the probability of not arriving at the appointment? Not arrived is 0.2. Probability, they are hoping that probability will be reduced. Probability will be reduced. And we have to test the experiment at 5% significant level. Test at 5% significant level. And we are going to, they are having the sample size. The sample size is 30. They are noting down the number of patients they do not arrive. This is the first step. We have to identify the keywords. These keywords will help us to answer the questions. The first part of the question is explain why the test is one-tailed and state suitable null and alternative hypothesis. So they themselves have told us it is a one-tailed test. But we need to give a reason why it is one-tailed. So when we go back to the main question, we can understand the probability will be reduced. This is the keyword for having one-tailed test. So because it is reduced, they look for reduction. So it is one-tailed test. So we have to write here. So the probability of reduction is expected so it is one tail test. So it is one tail test we have to mention or state the suitable null and alternative hypothesis. The null hypothesis is nothing but the hypothesis given in the condition given in the question. So we will have hypothesis, we will make it as H, which is the first letter of the hypothesis, and null, so we make it H naught. You can make it as probability of not arriving. Probability of not arriving will be equal to 0.2, which is given in the question. We can also mention this as H naught, which is P equal to 0.2. What is the meaning of alternative hypothesis? It is the hypothesis which is contradicting to this null hypothesis. So we are going to have H1 as alternative hypothesis, and we can say that probability of not arriving is reduced. That's what they expect. So not arriving is less than 0.2. So for stating the null and alternative hypothesis, 1 mark is given, and probability why it is one-tailed, that part is having 1 mark. So totally 2 marks for this answer. So you can see here from the marking scheme, it is H naught probability of not arriving 0.2. H1 probability of not arriving is less than 0.2, and looking for decrease. Okay, so it is if we have the same word keyword from the question, it will be giving mark for that. The next part of the question is asking us, use a binomial distribution to find the critical region and find the probability of type 1 error. So we have to use binomial distribution, and we have to find the critical region, and also we have to find the probability of type 1 error. 3 parts of the question needs to be completed. So before going to the answer of this part, we can just recall certain points. The test statistic is calculated from the sample. Its value is used to decide whether the null hypothesis should be rejected or accepted. The rejection or critical region gives us the values of the test statistic for which the null hypothesis is rejected. So when we look at these points, we can understand the null hypothesis is the focus here. So we are not going to think about alternative hypothesis. The null hypothesis is the main focus, whether it is rejected or not rejected. So if it is rejected, automatically the alternative hypothesis will be accepted. So no need to worry about alternative hypothesis. We need to focus only on null hypothesis. So the rejection or critical region gives the values of the test statistic for which the null hypothesis is rejected. The acceptance region gives the values of the test statistic for which the null hypothesis is accepted. Sometimes it may be mentioned in some explanation that null hypothesis is not rejected. That means null hypothesis is accepted. The critical values are the boundary values of the rejection region. So when we look at this table over here, the critical values for some commonly used rejection regions are given. So at 10% significant level, if it is two-tail test, it is plus minus 1.645. If it is one-tail test, if this is greater than mu naught, it is 1.282. That is the half of it. It is lying between minus and plus. For 5% significant level, for two-tail test, plus minus 1.960, and for one-tail you have here 2% and 1%. The significant level of the test gives the probability of the test statistic falling in the rejection region. So 5% significant level, 10% significant level. So we are going to understand how to calculate this values and based on the significant level. The next part of the question asks us to find the probability of type 1 error. So what are type 1 and type 2 errors? Type 1 error. So there are two parts. hypothesis, null hypothesis and alternative hypothesis. We are targeting only null hypothesis here. A type 1 error is made when a true null hypothesis is rejected. The meaning, when there is an hypothesis made, H naught, which is null hypothesis, it is true, but it is rejected. That means it is named as type 1 error. Type 2 error is when null hypothesis is accepted when it is false. Null hypothesis is made and it is accepted but it is false. Then it is type 2 error. So probability of type 1 error is equal to the significance level. So to carry out a hypothesis test on a discrete variable, calculate the probability of the observed or a more extreme value and compare this probability with the significance level. For one-tail test, reject the null hypothesis if this probability is less than the significance level. For a two-tail test, reject the null hypothesis if this probability is less than half of the significance level. So here, for a hypothesis test involving a discrete variable, the rejection region is defined like this. Probability of test statistic falls in the rejection region such that H naught is true. That means probability of type 1 error. Actual significance level of the test is probability of test statistics falls in the rejection region such that H naught is true, and this is also probability of type 1 error. All these points to be in the mind when we calculate the answer for the question. So diagrammatically you can see here left tailed means this is the critical value and the left of that critical value is the rejection region. And for the right greater than, that is one tail test, right tailed, it is right side of critical value. For two tailed, these two are critical values and the left and right are rejection regions for a two tail test. And here this is the boundary which we already saw in the table here. This is for two tail test. And here this is very important. This is the critical region line which we have here in the dotted line. Left hand side of critical region and right hand side of critical region are rejection regions for the values for two tail test. And if it is falling between the critical values, then it is do not reject H naught or accept H naught, which both means the same. These are the basic diagram which from which we will understand what is the meaning of the rejection and acceptance region. So this is the probability approach and we can understand using the probability approach as well. So now coming to the answer to this question, use a binomial distribution to find the critical region and find the probability of type 1 error. So first we need to find how to write the binomial distribution. So let us say that x, the random variable x, is binomially distributed with n and p. So here we are going to have n as 30 because the sample size is 30. So we will have x is binomially distributed with 30 and probability of success is 0.2. Because it is binomial, we need to have a q which is 1 minus p, which is 1 minus 0.2, which is equal to 0.8. Now we have to write the probability density function of the binomial distribution, which is a discrete distribution. So probability density function of a binomial distribution is probability of x is equal to x equals ncx p raised to x q raised to n minus x. So which is equal to here n is 30 and p is 0.2 raised to x and q is 0.8 raised to 30 minus x. So first we need to fix this using the given information. Then we have to find probability of x is equal to 0. We will start from x equal to 0, x equal to 1 and see which are the values for the probability is less than or greater than the significant level. the critical values. So find probability of x is equal to 0, which is 30C0. In the place of x, we will replace 0, 0.2 raised to 0 and 0.8 raised to 30 minus 0. So 30C0 is 1, and we can use the calculator and we can find this as 0.0012. And probability of x is equal to 1, we can understand 30C1, 0.2 raised to 1 and 0.8 raised to 30 minus 1, which is equal to 29, and we can use the calculator and find this answer as 0.00928. Now you can see these values which is at 5% significant level. What is the decimal form of 5%, which is 0.05. 0.05. So you can see these values are too smaller for 0.05. So we can find out probability of x less than or equal to 2. We can take the whole range, and probability of x less than or equal to 2 can be probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. So we can use these two values and we can find probability of x equal to 2, and then we can find that probability of x less than or equal to 2. We can add all these values and we can find that as 0.0442. So when we look at this value, you can understand that this is just below this 0.05. Now let us check for probability of x. So always we need, for discrete variables, we need to find two consecutive values. So since we have found out probability of x less than or equal to 2, we can check for probability of x less than or equal to 3 as well. So this is nothing but we can make probability of x less than or equal to 2 plus probability of x is equal to 3. No need to do it from the beginning. So this part we can take it from here, and we can say that 0.0442 plus 0. You can understand 0.07853, which is nothing but 0.123. This is probability of x less than or equal to 3. So you can see this part 0.0442 is less than this 0.05, but when you calculate probability of x less than or equal to 3, it is going to 0.123, which is greater than 0.05. So this is what we need to calculate, two consecutive values and understand. So we can see here probability for using the calculator, and these are the diagram for the probability binomial distribution. And so we have found out the values, two values, x less than or equal to 2 and x less than or equal to 3. So we understood that probability of x less than or equal to 2, probability of x less than or equal to 2 is 0.0442. So approximately when you have 0.0442, this is less than 0.05. So it is 0.05 for the 5% significant level. It is less than 0.05 will fall in the rejection region. So probability of x less than or equal to 2 is in the rejection region. So you have h naught is rejected for this value, probability of x less than or equal to 2. When you look at the probability of x greater than or equal, less than or equal to 3, it is nothing but 0.123, which is greater than 0.05. That means probability of x less than or equal to 3 is in the acceptance region, or h naught is not rejected. Okay, and probability of type 1 error, and you have here, you can say that probability of type 1 error is x less than or equal to 2, which is 0.0442, which is less than 0.05. So for this information, we have marks over here from the marking scheme. So probability of x less than or equal to 2. We need to attempt for 0 and 1 as well. Method mark 1. Probability of x less than or equal to 2 is calculated. Probability of x less than or equal to 3. So 1 mark for each. And then we can understand that the critical region is x less than or equal to 2, where probability of type 1 error is 0.0442 for 3 significant figures, and this will give us 5 marks. The next part of the question is, in fact, 3 patients out for 30 do not 3 patients out of the 30 do not arrive. State the conclusion of the test explaining your answer. So there are 3 patients out of 30, they do not arrive. So x is equal to 3 and n is equal to 30. We have probability of x less than or equal to 3 as 0.123. So we can understand that probability of x less than or from the second part we can take this value, probability of x less than or equal to 3 is 0.123, and we can understand that 3 patients out of 30 do not arrive, means it is in the acceptance region, and you can understand that there is no evidence that it is in the acceptance region. Why it is in the acceptance region? Because this is probability of x greater less than or equal to 3, which is 0.123 is greater than 0.05. So in the so this is the critical value. So this is less than 0.05. So here it will be greater than 0.05. Therefore, probability is greater than 0.05 means it is in the acceptance region. So if H naught is accepted, what is the meaning? There is no evidence. There is no evidence that probability of not arriving equal to 0.2 has decreased. So we have to write the conclusion in words. Probability of 0.2 probability of not arrived is equal to 0.2 has decreased. There is no evidence, because it is in the acceptance region. H naught is accepted means we have defined H naught as probability of not arriving is equal to 0.2. This is accepted. What is the meaning of that? There is no change. So no evidence that probability is equal to 0. P is equal to 0.2 has decreased. So for writing this in words, we will get points. This is the point given. 3 is outside the critical region. So for mentioning this, method mark 1 is given. No evidence that probability has decreased. Correct conclusion 1 mark. So totally 2 marks for this question. So hope it is clear for you to do the questions now. Thank you. Good luck.